Hello, I'm Carlos Rosa, and this is the CRS channel. We're going to continue with physics problems in kinematics, and we're going to continue with problem 3. Okay, we were considering the case of a person making a vertical jump, and we were assuming that the final height was equal to the initial height. And we were considering any points A1 in between A, the starting point, and B, that of the maximum height or the altitude of the jump, and point B1 between point B and point C, which would be the final point of the jump. And we had a list of times along with the list of velocities for each of these 5 points. So we were to find the basically the ratio between the time spent above half of the maximum altitude and the time spent below the half of the maximum altitude. And we obtained this ratio here, this one here, which for our case meant that this y with a curl was equal to 1/2 of h. And the ratio of those times gave us this value, 2.4142 approximately. Okay, so in the case of real jumps, we have that a person normally can make a vertical jump where the altitude h would be around 0.25 and 0.35 meters. In the case of not requiring running to gain impulse. That was normally known as the standing high jump. Okay, in the case of the high jump, known as the Fosbury-Flop high jump event, which is the high jump event using the Fosbury-Flop technique, which is the actual technique used for such athletic event. Here we have a table where we have the names of athletes, their height, the marks they made, and the approximate center of mass, the height of the center of mass with respect to the ground for these jumpers. This is an approximate estimate, assuming that the center of mass, the height of the center of mass of a person standing upright is at the height of the belly button. These values are given, were estimated also assuming a proportion with respect to the height of a person of 173 meters, assuming that that person's belly button height was 1 meter. Here we have the calculation of the altitude of the jump, which is basically the altitude given by the mark minus the center of mass height plus an assumption made here that the center of mass would be passing about 15 centimeters above the bar corresponding to the mark when the athlete passed over the bar. So these are the estimates for all the athletes. These are the times corresponding to the jump, which are given in accordance to basically the initial time, that is the time it takes to go from the starting point of the jump to the maximum altitude, which would be square root of 2 over g times h, which corresponds to this term, plus the time that it takes for the jumper to go back down to the landing point. C, which would be the landing point for the case of the jump, corresponds to the crash mat, and it is assumed that the crash mat is at a height of 1 meter. So these are the values, which are a bit different from what is assumed here, because it is assumed here that the landing point is at the same height or the same altitude as the jumping point. But in the high jump event, that is not so. This is the time corresponding to being above the half of the maximum altitude, which is the time given here, which was already calculated, which corresponds to this value here. With y equals 1/2 of h, so it would be this value here. 1/2 of h times square root times 2 over g within the square root. Remember that these terms were cancelled out when this ratio was calculated here. So these are the values, and these are the values corresponding to the time below or spent by the jumper below half maximum altitude, which correspond basically to the subtraction between these two values. This is the ratio for this time above half maximum altitude over the time corresponding to the jump. And this is the ratio of the time spent above half maximum altitude and the time spent below half maximum altitude. As you can see, only for the case of those cases in which the center of mass corresponded to the height of the landing mat, the assumed height of the landing mat, are those values for those ratios equal to the value estimated here, 2.4142. most of them are less and only one is greater because corresponded to the height of the center of mass height that was below the height of the landing mat, of the crash mat. So as it can be seen, the time involved in the jump is basically 1.1 seconds. The time above half maximum altitude is on the order of 0.78 seconds, and the time spent below half maximum altitude is around 0.32 on average seconds. Okay, so in the next video we're going to go now to problem 4.